looking at 23. It says water is leaking out of this tank at a rate of 10,000. So if water is leaking at a rate of 10,000 centimeters cubed per minute, what is that? dV dt. Volume is the centimeters cubed. So I'm going to go ahead and write that dV dt is negative 10,000. And it says at the same time that water is being pumped into the tank at a constant rate. The tank has height 6, so I'm just going to write height equals 6 here. And the diameter at the top is 4, so I'm assuming I'm going to need the radius instead of diameter, so radius would be 2. And just make sure all the labels are kind of matching up. I'm kind of having an issue with some of the labels already. What do you notice? Some are meters, some are centimeters. So let's switch these meters to centimeters. So 6 meters is how many centimeters? 600. So let's just switch those. And so the radius will be 200. If the water level is rising at a rate of 20, so what is that? dH dt. My height is changing with respect to time at a rate of 20, and that's in centimeters, so we're good there. When the height of the water is 2, when h equals then what? Not 2, but 200. Find the rate at which water is being pumped into the tank. So we're trying to find the rate at which the volume is being pumped in, right? I'm going to adjust something that I have written here. Okay, this is how fast it's moving out of the tank, right? But then I'm also pumping stuff into the tank. So this isn't the actual rate of change of the volume with respect to time, is it? Okay, this is just how fast it's being pumped out. And then how fast it's being pumped in is going to be like another piece to that. So this is going to need to be adjusted. Let's start by writing the equation for the volume here. So what's the equation for volume? So we've got volume equals a third. If it comes to a point, it's always a third. And then area of the base times the height, which would be pi r squared h. Okay, so the actual height is always 600. The actual radius is always 200. But it's not always filled up to that level. So if we say it's filled to this level here, I'm going to have a new triangle, but it's going to be a similar triangle, isn't it, to the big one? Okay, so this piece here we'll call our R value. And this piece here I'm going to call my H value. So if I set up similar triangles, R is to H as what? 200 is to 600. Now my picture might not be, great there, but if you pulled those triangles out, you'd have that. So we're probably going to have to use that there. So I'm given dH, dt, and h. So I probably want to keep my h in here, right? But do I really want to keep this r in here? No, because then I'm going to have a dr dt to deal with, and I don't want that. So I'm going to replace the r with the h from this piece. Okay, so let's do our cross multiplying. We have 600r equals 200h. So to get r by itself, you just divide by the 600. So my r is a third of h, or h over 3 if you want to put it that way. So let's put that in here. And we can try to simplify that. So we're getting somewhere here. We're obviously not all the way through, but so this is going to turn into h squared over 9. So if I have h squared over 9 and then the third there, I've got pi in the numerator of this number. And what's in the denominator of the number? 3 and 9 is going to give me 27, right? And then how many h's do I have? H cubed total, right? Because I have h squared and h. Okay, so this is going to be the equation that I'm using that just relates the volume to the height. Go ahead and take the derivative of that. And we're going to have to figure out how to plug in for dv dt so we get our right answer. So go ahead and start with that, and then we'll try the next piece. So if I take the derivative, I get dv dt equals, if I multiply by 3, I just get pi over 9h squared, and then dh dt. Does that look okay to everybody? So what am I plugging in for h from above? 200. And what am I plugging in for dh dt? 20, right? Now my volume is actually changing at a rate of this negative 10,000 plus whatever the rate of the water being pumped into the tank. So let's just call that dp dt. Does that make sense? Okay, so I'm going to put that in for dv dt here, and we'll see if that gets us the right answer. If not, we'll have to think a little bit harder on it. But okay, so the volume's changing at a rate of what's being pumped in minus what's being pumped out there. So go ahead and see what you get for dp dt, and that's what it was asking for, the rate at which the water is being pumped into the tank. Should it be positive or negative? Positive, so try it and see what you get there. So that's looking right. It looks like it matches the answer key. If we do it to a decimal, it's like a really pretty big number, isn't it? Because we have 10,000 plus all of this stuff and the 200 squared. But remember, it's in centimeters cubed, you know, so it's maybe not as big as it might seem there. Do we get like 2.89 times 10 to the 5th? Okay. Now, you wouldn't have to write it like this, but that's what the answer key has. That's why I was asking that. What would the label be for the rate at which it's being pumped in? Centimeters cubed per minute? I think it was minutes. And it would be in centimeters because we converted to centimeters. If you converted everything to meters instead, then obviously it would be the other way around. And the number would be a lot different.